learning here the position and velocity. The question based on position and velocity, which are the applications based in your calculus part. Okay. So let's begin this one. So what are the basic formulas for this one? So formulas in this fifth position, if you will defining the position with respect to time, let us define as a function of time x of t. Sometimes many times for the s for displacement, s of t is also used. Now the velocity, what will be the velocity? Velocity is dx x dash of t, the prime derivative for the t, or dx by dt. The position with respect to time. Sorry for that. Position with respect to time, that will be your x dash of t, or x first derivative for x of t. So that is going to give you the velocity in this case. Now what is the acceleration? If you will work here with the acceleration concept, observe. So acceleration a of t, acceleration with respect to time, is the second derivative of position or displacement with respect to time, and the first differentiation, first derivative for the velocity. And we can write this in other way as x d2x. We have here d2x, d second derivative d2x upon, this is the first one. Or for v, velocity, we can write it as second derivative. This will be dv by dt, or we will write is a dv by dt there. So velocity with respect to time there. So this is what we are having here. So if you'll observe v dash of t and dv by dt there. Right. So let's begin with the one example here, so that will make you more clear these concepts here. So let's begin. Question is that if position of particle at time t is given by x of t is equal to t cube minus 11 t square plus 24 t. Find velocity and acceleration of particle at time t equals 5. So 5 seconds, that will be your time period. What is given? T equals 5. We'll assume it in a second. Okay. So first, what will be our first step now? We will be taking, first step will be our taking the differentiation or the derivative. Derivative will be our first step. So let's take the derivative for x of t here. Okay. So what is the derivative we'll be having here? X of t, that will x dash of t. This will 3t square minus 22t plus 24. So 3t square. So we are getting, can anybody analyze this one, this part, this one? So if you observe this one, uh, the origin, what was origin question we had? T cube. We were having t cube there. What was, what was the part here? It was t cube. So original question was t cube minus 11 t square plus t cube is becoming 3t square. As you know that x raised to n, it will become x raised to n minus 1. The same formula of differentiation we are using here. 3t square. 11 to 2 times 11, that will 22 into t, negative sign as usual. And 24 into the differentiation of t is 1 here. So d by dt, t by t, the differentiation is 1. So we got here 3t square minus 22t plus 24. So this is what we got. Now remember what we got, this the first part, the first derivative for x of t, or position or displacement, that is nothing but velocity at the time t. This is what we are having, velocity time t. Now question is that, next question, what they are asking, what is the time period given in this case? Is a time period given, that is t equals 5. So as we are considering this t equals 5, we will be using the same concept or same position, same value of t in the given equation to plug these values. So what values will be having here? So if we'll just go for this one, we'll plug t equals 5 at this time. So if you are plugging t equals 5, what you will be getting here? V of 5 is equal to, this is very easy, 3 into 5 square minus 22 into 5 plus 24. Solving, will be getting negative 11 as your answer. So this is your part, what you got here. Now, if you'll take consider of derivative for v of t, you will be getting a of t. Differentiation of the velocity, that is second differentiation for this, will be your acceleration. So differentiation for velocity of t for this will be 60. 60 is the differentiation what we got. What was the question here? What we had here? V of t, what v of t was there? It was 3t square minus 22t plus 24. So 3t square, we are getting 16 here. Negative 22t, that becomes negative 22. And this 26, this is whatever value you are getting, 24, sorry, the value, I'll write it properly. Yes, 24. Value 24, that will be becoming 0. This will become 0. So constant. So we got acceleration as 6t minus 22. That will be acceleration for t there. So this is what we got acceleration for t at t equals 5. Now finally, we'll plug t equals 5 to find the acceleration at that time. You'll be finding acceleration at that time. So a of 5, that will be 6t minus 22, what we got? 6 into 5 minus 22. And that is equal to 8. So 6t minus 22. This is original what we got acceleration. What was a of t? Once again, I'll revise what is a of t here. That is 6t minus 22. So t is replaced. I'm replacing this t with 5, plugging in the value 6 into 5 minus 22, that will be 8. Now see negative velocity. The sign of velocity is important because it indicates direction. Remember, what is it indicating? That is going to indicate the direction here of the motion of particle. Okay. So make sure that you know the following here. So what is to be known here? That what signs you are getting. You should be well aware of the signs here. So as a result, this is what indicating the direction. You make sure that you know the following parts, that what is following, when will be getting positive, when it will be a negative. What are the following parts? Required, that one positive. Negative, that will be deceleration or deceleration. And positive, that will be a positive acceleration. That is your be acceleration. The speed is increasing in this case and decreasing in this case. These are the points that you must consider while getting the answers or whatever answers you found in this case. Okay, thank you.